A warm welcome from Zurich to all of you out there. Thank you for taking the time to listen in today. We have participation from all over the world, different time zones, and I'm happy to see we have great participation from the West Coast. It's kind of early for you guys, so I hope you already had your first cup of coffee. Let me get started with my presentation here. My name is Philipp Geering. I'm the CEO of ADVANTIS. For the ones that don't know me, but I saw on the registration list, there are many, many familiar faces. But welcome to all of you new guys that don't know us yet. And as I mentioned, just relax, sit back, and enjoy the show. We will go for 90 minutes. I hope I can get through all the content. There is quite a bit of content prepared, but I do want to get some questions and comments in, if ever possible. So we'll see how it flows. And I have some extra material I'd like to show that is kind of new stuff for the future, but I'd like to do a little teaser if time allows for it. But I'm respectful of your agenda, so we'll cut at 90 minutes. Back in October, we launched our new channel called ADVANTIS Academy, which represents our knowledge transfer channel. So this is our second webinar that we're doing under this channel, amongst also training courses. They all fall under this label called ADVANTIS Academy. So the first of this kind of webinar we held in October last year. And you can find that one on our YouTube channel, which is linked on our website. And that is also about 90 to 100 minutes. So with all that said, let's get started. Make sure I got all my monitors here lined up. Having 5 monitors sometimes helps, but sometimes is a bit of a thing to manage. So before we get started, you are being recorded, which means we are recording this session as well, and it's going to be on YouTube in a few days. It's going to take some time, but we will upload this as well. The way this platform works, Demio, is you are all muted. We can't see you unless I bring you on stage. So they've just recently introduced this new concept with the stage. I will bring, let's do that right now. I can bring our COO, Stefan, on stage just to show you how that works. So the way we want to run this is, if you guys have a question, put it in the chat, or just put the raise hand symbol up in the chat. Stefan will track all this, and then we'll go through all your questions. Or if you want to verbally express your question or your comment, we will put you on stage. So let me try that as a sample real quick. Gotta find Stefan down here. I'll invite him on stage. He has to accept, and eventually he's going to show up with.
Hello.
Yeah, there he is. We can hear and see him. And guys, I think he looks so much like a COO with his headset on. So he's going to be in control of the chat and let me know if there's any question. So thank you, Stefan. I'll put you off stage again, if you don't mind.
Thank you. Sure. Yes. Thank you.
Remove from stage. Okay. So that's how it would work if you guys want to say something versus writing it in the chat. So. Let's talk about the agenda. Sorry, got to get this one off. So, agenda for today, we'll do a brief introduction about myself, again, for those guys who don't know me, and briefly about who ADVANTIS is. We then dive into or look at the current situation on standards, and that's the amusement industry standards as well as the reference machine safety standards. We then open up the floor in case you have some specific questions on standards, because that obviously is a big driver in what we're doing on risk assessment, is what those requirements are. And as you see, we're going to look at EN, ISO, and ASTM. Those are the three relevant standards. I'm aware there is the GB code as well to look at. But our focus right now is to make sure we harmonize these requirements amongst these three standards, and that we have full coverage and compliance with these standards. Then we go into the actual core of this presentation, of this webinar, which is a step-by-step guide or instruction through the risk assessment process. So it will always have a theoretical portion to it, where I give insight of what's going on the standard side, especially ASTM. And then I will share also some examples. So although this is not meant to be a product presentation, I will use ADVANTIS to show examples of how this risk assessment will look like as an example in ADVANTIS. So then we will also then stop here with the Q&A session for any kind of questions. But feel free to put your questions in the chat while I'm presenting. So with that said, let's get started. Myself started in '96, got my bachelor in electrical engineering, and pretty much ever since then worked in the industry for 25 years now, over 25 years, primarily on controls. So that's my core competency is control system design, and then more and more risk assessment as well. Functional safety, obviously, big portion of our work in controls, and I got my certified functional safety expert certification back in 2001, where all this was very new. And so ever since then, been doing a lot of functional safety work. I am an accredited ride inspector, and I was actively doing work between 2015 and 2019 in the Dubai area for an inspection body. I'm a member of the CEN TC 152 and ISO TC 254. Those are the two technical committees responsible for the EN standard and the ISO standard. And my responsibility is electrical equipment and control system. I'm also a member of ASTM F24 as of last year, also a member of the exec committee. And on this new standard that is being developed for risk assessment, there is a task group, and the task group is a large task group, about 100 members, and 7 are in this core, in this main task group, and myself and Kevin Russell, who is eventually also on the call, at least he registered. The two of us, we're the co-chairs leading that effort in on this new standard. Last but not least, I'm a member of the IAPA safety subcommittee here in Europe for the EMEA region, where we do a lot of work for our members when it comes to safety as far as best practice. We organize Safety Institute once a year, where we give presentation, where we give actual like accident reports and what went wrong and these kind of things. So that's what the safety subcommittee does. Okay, enough about me. Let's talk about ADVANTIS real quick. So established in 2014 in the heart of Switzerland. So this is the actual lake where we're situated near Zug. Beautiful area. If you want to come, you guys want to come to our headquarters. We're a team of 9 by now, motivated individuals. working on the software. The core or the majority of our individuals are in Vietnam. That's where development is. It's a growing team of developers out there, and Stefan is managing them from here with great success. We are in the business, and that's our vision, to be the best of class amusement ride risk assessment software. That's what we're aiming for, and continuously working towards that goal, that vision. We have a worldwide customer base by now, which includes ride manufacturers and parks. And as we're enhancing our product on a monthly basis, we have monthly product releases. We are currently boarding a few more customers. So it's looking very promising, establishing a large customer base in this industry. If you have any specific question, obviously at the end you'll have my email, and you can ask further detailed questions. So with that, let's start on the first topic with the standards. So the first standard I would like to talk about is the EN 13814, which I said is developed by the CEN-TC 152. Originally, it was created in 2004, but now got substantially updated in 2019, and it is now adopted by pretty much all the EU member countries plus others. There's a total of 42, 43 countries that have adopted the 2004 version, and they're like now migrating to the 2019 version. What is new in this version, and that's important, is requirements on risk assessment called DRA and OERA. DRA stands for Design Risk Assessment, and OERA stands for Operation and Use Risk Assessment. So those are requirements that tell the designer manufacturer of what he needs to do, and also what the owner operator needs to do. That's the concept that EN chooses. That was honestly before my time. On ASTM side, we're not separating between the two, but we'll talk about this maybe down the road a bit more. But it is important that this is out there, and this is a requirement, which means in the past, there was only a risk assessment. In the 2004 version, there was only a risk assessment required by the manufacturer. This has changed. Now the park also needs to do a risk assessment. And so that has some impact. As a matter of fact, I just did an interview with EAP, the magazine here in Europe, together with two TV individuals on this very topic, to kind of start informing, especially the parks, that there is going to be a requirement going forward for every new ride installed in an amusement park in Europe. There has to be a so-called OERA, Operation Use Risk Assessment. So certainly something that will come up more and more. On the ISO side, we have this 17842 standard. This has been out since 2015, developed by this according technical committee 254. And it was revised last year. We're still in the final steps of revision. It's been only adopted by a handful of countries so far. But the good news is it will be 100% harmonized with the EN standard. So those two are in line as far as content goes, which is great. So as a manufacturer, you don't have to look at potentially contradicting requirements. So last but not least, ASTM. For the ones who know, there's about, I don't know, don't get me on it, 17, 20 standards, different standards, where on the EN side, you have three parts, part 1, 2, and 3. Same on this guy, 17842, we've got three parts. Here, as I said, we got about 20 standards, and the committee is called F24. And what's also unique about it, not just that there's many different standards, is they're constantly evolving. So there's pretty much at least one revision or new version per year, sometimes even more than one, which has good things, but also bad things. It is mandatory in the US, but also adopted in many other countries, such as Central and South America, amongst others. What is new, hopefully in 2021, I don't know, is that we have the complete new standard on risk assessment. It looks promising that we are done with the content by late summer. So eventually we should be able to go out and do an initial ballot round the end of the year, let's say fourth quarter of this year. But you got to understand how ASTM works. There's about 1,100 members in this F24 committee. And if one guy says negative on something, we have to address it. We have to look at it. So it's not a majority vote. We basically cannot pass a new standard if there's one negative vote. We have to resolve all these negatives. So we might need some patience before we get through and have it out there. We hope not, because it's such an important topic. But because it's such an important topic and because it affects everybody, there's a lot of attention to it. Hence the 100 members in our task group. So next topic is the machine safety standards that are being referenced by the industry standards. First one is ISO 12100. So this one is referenced by the EN and the ISO standard. Because up until now, we didn't have specific requirements on risk assessment in our industry. We simply pointed to this standard here, to ISO 12100. But the thing is, it is focused on the machine and it's focused around the machine builder. So it's not really a good fit for us. Hence the need or the desire to create our own industry standard. But it covers the fundamental process of what a risk assessment is. And that's why we're looking heavily at this guy as we're developing the ASTM standard. The next or similar standard is NCB 11.0. This is actually very similar to ISO 12100 out of the US. And we're also using this work in our work at ASTM. It's also machine safety standard, but it includes the user. So it has a bit of a larger scope as it looks not only at the supplier, but also at the user. So we like that concept. So that's the thing we've taken on in our work. So as we then ballot, you'll see a lot of references to those two standards as we go forward. So in a nutshell, that's on the standard side. We have a first question. Let me see. I can read it here myself. Jim asks, if EN 13814 and ISO 17842 are to be harmonized, would it be simpler if one was just withdrawn in favor of the other? Hell yeah. Thanks for asking that question, Jim. Being a member of 3 committees, let me tell you, it's a bit of work, you know, and so definitely want to get there. There is a so-called Vienna Agreement between ISO and CEN in this case, where you could do this. You basically withdraw one and then it becomes an EN ISO. But at this level, things become a little bit political, especially because ISO is the chairman and the secretary is run by the Russians. And we Europeans, so to say, are a bit reluctant of just saying, okay, let's forget about EN, let's just go under ISO and do that, because we lose influence. We lose a lot of influence because all of a sudden you got a lot more countries having influence on the content. So we could see the Vienna Agreement if it goes the other way around. If EN has the lead and ISO goes under EN. So short answer, definitely that's where we're going to get there. Do I see this, or more my kids or grandkids, which I don't have? Probably, because it's political and won't happen overnight. So any other question, any hand raised? I don't see anything right now. So if not, we'll continue. It's fine. So let's talk about the risk assessment process. So what I'm about to share with you guys is content from ASTM. This is not Phil Geering having a good moment kind of drawing type thing. So if on certain things that are like my flavor, my recommendation, I'll say that. But what you see is understand it. This is not the way I think. So just to make that clear. So that's why it does say source F24 down here, sorry, wrong cursor. So very simple, straightforward. Here's the process. We've got 4 steps in it. Prerequisite, hazard identification, risk estimation, risk evaluation, and risk reduction, and results. So some of the content is even new to some of the guys that are in the contributor lists that have seen the draft and have given feedback. We've recently updated some content, so there is some new information even for you guys. So let's get through these steps. First one, prerequisite. Prerequisite is further separated into the following boxes. We first have to build our risk assessment team. We then need to collect information for our risk assessment. And then we need to define the scope of the assessment. We put a little box around these 3 because those don't necessarily need to go in a timely sequence, but this is just work that needs to be done before you start the actual risk assessment. Only if you have that first step done, you can then define your task, which is a pivotal thing in a top-down risk assessment. So that's why to define the task is here a separate item. So let's look at these individually. Build your risk assessment team. So make sure it is a team. One person is not a team. I've seen and heard of many risk assessments that were conducted by a single person. This is no good. Don't do that. Always be at least 2 or 3, if not more. Make sure you recruit competent and experienced team members. Experience is a big contributor here. Make sure people have experience in what they're doing in order to make this a powerful and good risk assessment. And then look for diversity, especially for the owner-operator. So the parks that you have background from operation, background from maintenance. On the designer-manufacturer side is a bit of a challenge because we're all designers and we can only assume how it's being maintained and how it's being operated. But still, look for as much diversity as you can when conducting the risk assessment. Input information. So when do I need that? Make sure you have all the information available prior to start the assessment. That is key. So what is it? What kind of information? For the designer manufacturer, it's often referred as a theory of operation document. This is the centralized document that you really want to have in place before you do your risk assessment. So what is the content of the theory of ops? It has a basic ride description. That's important. So people that read the risk assessment and read the theory of ops first have an understanding, okay, so this is the concept, this is the type of ride it is. It should have a detailed description of all the operating station where employees interact with the machine or with the ride. That is important. And then most important is a functional description of how the ride is being operated in every use case, in every operating mode. That information is so important to have in order to make a good risk assessment. And when I say good, I mean a risk assessment that is actually connected to the ride and not some high-level document that exists but has no connectivity to the actual design. So very important, early in the process and very complete as possible, only what you want to do, how you want to operate this ride, not looking at safety at all, just what should it do. From an owner-operator's perspective, if you have to do this OVORA, you should have a standard operating procedure eventually, or if not, you just go with the ride manual from the manufacturer who tells you how to operate the ride. So at least that piece of information you need to have before you start your assessment. The ASTM standard will have some examples as well, what else you need to consider. So scope definition, next point, very important. Why? First of all, your team needs to have an understanding of what is in scope and what is out of scope. Second, if you're a designer manufacturer, your customer needs to know what you're considering and what not. Are you considering a spectator of your ride or not? Are you considering a person walking up the entrance queue line? Yes or no? What is in scope? What is out of scope? That is a new thing with this DRA OVRA, where you really, especially as a designer manufacturer, you want to set the stage and say, look, I'm going to look at my equipment that I deliver. I don't consider somebody else's equipment. I only look at my equipment and communicate that early to your customer. And that's the third point, early communication. The park needs to know what the manufacturer will consider so that they can accommodate to it, because somebody needs to integrate all these different subsystems into a large attraction. And they need to make sure the interfaces are covered. And any risk that is not being taken care of by the supplier eventually needs to be picked up by somebody else. We call that transfer risk. And we'll get that at the very end. That needs to be documented. Very important. So, last point, or next step on the prerequisite, we haven't even started the risk assessment, we're still doing prerequisite, is the definition of tasks. So why tasks? That's the difference of a risk assessment versus, for example, an FMEA. An FMEA looks at an existing design and does a what-if analysis. And if you do a task-based, and that's what ISO 12100 clearly asks, chapter 5.4 clearly says, you shall define a task first and do a task-based risk assessment, top-down. Because with an FMEA, you simply don't see certain hazards. certain hazardous events will not occur if you just look at an FMEA. What if that bolt snaps? What if that bracket falls off? What if? So you got to understand there's a fundamental difference between a risk assessment, top down, and an FMEA being a bottom up. So always start with a task. When you start with a task, what you want to do first is define your use cases. And the use case concept is kind of new. It's been established for some time in ASTM, not in Europe. Or Disney has been using it for a long time, this concept. And the use case is, for example, regular operation is one use case. Irregular operations, such as evacuation, is another use case, or preventive maintenance is a use case. So those are different use cases, and you want to define those first. What use cases do you have on this particular ride? Within the use case, you can then define the tasks, and the task is how people interact with the ride in this particular use case. So regular operation, a passenger boarding a vehicle. This is a specific task in that particular use case. All this needs to be defined and thought of first in some sort of a brainstorming session to define all these different tasks. And there's different approaches how you do this, but one recommendation is you take a use case, you take a particular type of person, and then you go through the entire attraction and say, okay, let's look at the guest first. How and where is a guest potentially being harmed? And then you look at an operator as he's working there. That's why you need the theory of ops first, because you need to know where he's operating and what he's doing. So that needs to be defined, and then you can do your task definition and subsequently your hazard identification. So very important to write down all these different tasks. And as I said, make sure you cover every person. So that is the guest, maintenance technician, operating staff, eventually even other workers, contractors and such that just occasionally work on the ride, if they are within your scope. Goes back to your scope. Very important that you got your scope definition done. So, time for an example. And now let's see. I'm going to switch over. Eventually, you see now the ADVANTIS screen. Okay, so on our production server, I just have a small example here, webinar 2021. We call it the base module. Sorry, wrong here. I got to drive it from over here. Sorry, guys. I can't look in the camera right now. So when it comes to scope, for example, here is a list of what your potential people are interacting with the machine. So we have a passenger. That's the person sitting inside a vehicle. We have a participant that is, for example, a person in the entrance queue line or on the exit ramp. And then we have a spectator. That is a person outside the ride perimeter watching. So then we go on, we have a technician, we've got an operator, and then in general, sometimes we have hazards associated with just any kind of person. So we have that definition as well. And then here you got the option to define what is in scope and what is out of scope. The same or similar for use cases. So use case regular operation, we can define, say, look, in scope is any risk related to supplied equipment. And then you can also do detailed design, detailed description of what is out of scope for every one of these use cases. Then you got the option here for additional user-defined scopes. And one very important one is the human behavior one, where you can make a statement, and you should, independent of the tool you're using. make a statement of like what is in scope as far as like the terms. In this case, we're saying foreseeable human behavior is considered. And sometimes, tolerable behavior. And Ian has an appendix that has a statement in there. So you might want to reference that one just to make a clear statement of what is in scope as far as human behavior, because that is very unique to our industry. We are dealing with humans, and humans don't always behave the way we anticipated it and the way the ride was designed. And where's the boundary? What can be accepted or has to be considered in a risk assessment, and what is just too far out there that I should not consider? For example, here on the employees, we're making a statement here: intentional misuse and intentional technical sabotage is not considered. So, it's just very important that you have it on paper somewhere. So that's on the scope. On the actual ride, within ADVANTIS, you can design your ride in this kind of architecture, and you just you have your subsystems here that you create, and then what is nice about it, you can just use it in your task definition. So your next step is your task definition, and here you just define what is going on. So in this case, we have a participant walking at entrance queue line. So who, where, in which use case, in which operating mode is doing what. So that's an example, and I'm going to take this participant walking at entrance queue line then to the next step. I'll take it all the way through to show you this example. So it's going to be here where a participant is going to be jumping the entrance queue line. So we'll see how that goes. So that's here. We got 40 minutes in, so we're doing good. Let me change back. Okay, back to our process. So the next step is, now that we're actually starting with the risk assessment, the first step is the hazard identification. And hazard identification has 3 parts to it. First of all, you want to identify your hazard. Then you want to identify or define the hazardous situation with this hazard, and eventually explain possible hazardous events. So how does this all work? How do these terms correlate with each other? So we'll start with the person. So based on what we just saw, the task tells you how a person is interacting with the ride. The ride, A or D, has many hazards, or also called hazardous zones. So a hazard zone and the person, the combination, creates a hazardous situation. So a hazardous situation is in this picture down below there. That's actually Zurich main station. That nothing has gone wrong. Nobody is harmed. It's just a hazardous situation where you got people and you have a hazard close by. And if something goes wrong, you end up with a hazardous event. And so by definition, because we put people on a machine that can potentially kill these people, we just have hazardous situations all day long. What is now the key is, how do we get from hazardous situation to a hazardous event? Because in a hazardous event, things go wrong. This is where the hazard is going to harm the person. And the missing link is the probability of occurrence. So, and this is actually a chart, again, source ASTM F24, where we explain all this in the draft, in the new standard. And by no means this is our own invention, because this comes from, in this case, it's ISO 14121, part 2, has all this laid out. And so this is nothing new. This is just how it is, the correlation between these terms. And I think it's important for everybody to understand what these terms mean and how does all work. So again, you transition from a hazardous situation, and if you look at the picture down there, it's, don't, think about it, but that baby in there is not doing anything wrong, but this thing is going to become bigger and run around at some point. And when it runs around at some point, it could lead to a hazardous event if you have no control over him or her. So that's where a hazardous situation, just being close proximity, becomes a hazardous event. What is the probability of occurrence of harm? This is what we're going to look at now in the next part, then, in risk estimation and risk evaluation. Time for an example. All right, let's switch. Hold on. I get right here. So if we look at this participant jumping guy here, so we got the task defined, participant walking at entrance queue line. The hazard is of category human, so it goes into the human behavior category. He lost his cell phone on a previous ride. He's highly motivated to recollect his cell phone. And by the way, this origin effect consequence, this is something that comes from the ISO standard. This is just a wording. So I'm just putting in the blanks here. So loss of cell phone, motivated to recollect his cell phone. Consequence, he's going to jump the fence. So we have a hazardous event that a participant is being hit by a vehicle during his recollection of cell phone. And that's because the ride is at the very low to ground and very high speed. And we'll get to that in the risk estimation. By the way, this example is real. This is an example from a ride that I commissioned 3 years ago in downtown Paris, where the park decided to put the queue line right through the ride envelope, right next to a low to ground high speed section on a very quiet ride that you don't hear coming, and it'll kill you. So this has not happened yet, but the way this is designed with the fence, not sure. And I'll get to that when we talk about risk reduction measure. So that's on hazard identification. Let's go back. Here. Back to the process. So next step, risk estimation, risk evaluation, risk reduction. Very important. Risk estimation and risk evaluation are two separate steps. So we estimate our risk elements first. We then evaluate what the resulting risk is. Then part of this evaluation is the risk acceptable, yes or no? If the answer is no, we're going to go into this reduce risk reduction measure box here, because we have to do something. The risk is too high. You got to reduce it. And then reassess. And so this is this iterative process that you continue with every hazardous event that you've identified. You have to go through this until this answer, the answer to this question here is yes, and then you go to the next box called result. So let's look at that. So risk estimation. The content is the two risk elements: severity of harm, probability of occurrence of harm. So here it is, you know, that arrow down. What is the probability that this event is going to happen? As we're now releasing this ASTM standard, we're only considering those two parameters. There are standards out there in concept that consider more than these two, but those are the fundamental two that you need to look at. Basically, how bad is it, severity, and what's the likelihood that it's going to happen? Because only that combination is risk. Harm is not a risk. It's the severity and the probability of occurrence, those two. What is important? What is very important is always to include the initial estimation without any safety measure in place. I've seen many risk assessments where that is not there. It's basically just a list of things, what have been done, and then a final assessment saying everything is good. The problem with that, if you don't do your initial estimation without any safety measure in place, you never know how bad it is. And if you don't know how bad it is, you never know if your risk mitigation or your risk reduction measure is sufficient to this initial risk. So it is very important that you always start blank without any measure in place. So on that fencing thing, basically no fence at all would be worst case. Just a path. It's like, here, queue line, walk through. Here's the ride, here is you. You just stay here, don't go there. So that's important. Second thing, very important, justify your selection. I've seen many risk assessment, which is a number, just whatever, it's catastrophic, it's severe, but no justification for that particular selection, which means, you know, if you're in front of a judge and you need to justify your selection or say, well, why the heck did you choose this parameter? It's wrong, obviously, because you said this is going to happen, but that happened. It's fundamentally important that you justify and describe or put comments in your selection, because 2 weeks after you've done it, you don't know why you picked that level. So risk evaluation. The content here is determining your risk level. And there's different methods out there, such as risk matrix, risk graph, numerical scoring. Those are the three major ones. On the ASTM standard, we are not telling you which one to use. We give examples that you shall pick a method, and you have to have a method, but which one, we leave it open. Because, as I said before, it's going to be hard to get this standard out anyway. If we are too prescriptive in defining certain things, then we feel we're never going to make it out of the gate. So we'll leave it open. If in whatever, 5-10 years from now, the industry says, look, everybody's using a risk matrix anyway, we might as well put this in the standard. This is industry best practice. Let's just use a matrix. Then comes the question, well, how many levels? How many levels this way? How many levels this way? So that's the next step to agree on. So again, maybe my grandkids will then say, look, Grandpa, this is it. We have a matrix 4x5. You did it already in ADVANTIS 25 years ago. Good man. But I don't think that's going to happen. And that's not the problem. Let's just start with the process. Let's start with the fundamentals first before we go in these details. What is important is that it's a separate dedicated step. Evaluation should not happen at the same time as estimation. So you should not look at the result as you're estimating your parameters. Say, what do I pick? This one. Oh, I'm already tolerable. Yeah, let's pick this one. So you should really think of your parameters first, and then look at the result in a second step. What is recommended, not just by myself, but we put this also in the standard, is have more than 2 levels. The minimum is 2. Your risk is either tolerable or intolerable. So there are companies out there that use red and green, those 2, be done. I recommend to have an intermediate level for multiple reasons. One reason is when it comes to risk reduction, you can then say, look, if I'm intolerable, an administrative measure, basically an operator cannot get me from from intolerable to tolerable. Can only get me to orange, or from orange, undesirable, from undesirable to tolerable. But an administrative measure cannot take me all the way down. That's one example, or one reason for having more than these than 2 levels. Sorry. Next item is, where are we on time? 25 minutes. Good. Risk reduction. So what you have to do here is you phrase your risk reduction measure, RRM. What is important? To be specific, and that's what I meant earlier. A risk assessment is only good if it's specific, and I'll show you my example what I mean by that. I don't mean specific in a way like I've seen many assessments that put, which Papillon-Fuchs sensor they're using here in the risk reduction measure. I'm not about the solution. It's what needs to be done in order for the event not to happen. That's what you need to think of. So that's why so this is a Phil Geering thing. This is not the standard. This is me. Recommend to separate the risk reduction requirement from the solution, because then you can word your requirement very early in the development. In this case, the fence shall be of such a height that you cannot just overcome, or when you designing a round ride, that the mechanical system shall be designed to withstand rotation up to 10 meters per second, 10 RPM, sorry, 10 RPM. That's what I mean by specific. Be specific on performance requirements, but not prescriptive on like the detailed solution. That the solution comes later, and that's what this separation allows you to. So you can put out the requirement, which is then an input information for the designer. They know, okay, risk assessment says I should design this ride so it can withstand 10 RPM. And you can be sure we'll tell the controls guy to design a safety-related control function that kicks in at 9 RPM. And then we have a safe case. We build a mechanical system that can rotate up to 10 RPM, and we have a control system that kicks in at 9 RPM. Just make sure that functionally your theory of operation did not ask for a rotation speed of 8.9 RPM, because you're going to have a lot of nuisance faults. But if your theory of ops calls for 8 RPM as a performance parameter, and then your overspeed kicks in at 9, and your mechanical system can run up to 10, you have built a solid design. And having this requirement solution separation is really helpful for that. It also is considered a closed loop assessment because it requires you to close the loop. Whatever you define early on, you need to close it. I know there's other methods out there where you just have like a follow-up, or you have like you assign for any risk reduction measure, you assign a responsibility to someone to make sure this is addressed. But we at ADVANTIS, we believe in this concept. So, speaking of which, time for an example. So, switching gears. Okay, so sorry, got lost here. So we're doing risk estimation, risk evaluation on this guy jumping the fence. So 2 parameters, severity and probability. In this case, we have 4 levels here defined, what they mean, from worst, catastrophic, all the way down to insignificant. We have a probability, in this case 5. By the way, ADVANTIS lets you have, down to 3, up to 9. You can choose, you define whatever you want. Tool is very flexible on that. And then we have these 2 comment boxes where we can say, look, collision with vehicle, specific numbers now, moving at 15 meters per second will most likely result in a fatal injury. That's why we pick catastrophic. That's our justification. On the probability, we have a ride that has 700 people, oh, not M, sorry, pph, people per hour capacity. And we pick a moderate probability of occurrence for someone to jump the fence at the moment of a vehicle pass through. Now, this is clearly the team estimating that. But this is the justification. If you don't have any words there, you don't remember why you picked moderate. What was the justification to pick moderate? But now, at least, okay, good. We know the capacity. And the chances that somebody is jumping the fence right when the vehicle approaches and not paying attention, the chances that he's going to jump the fence, or if there's no fence, the yellow line on the floor, is obviously high. But the team decided it's moderate that it happens at the same time. So this is how we got to these 2 parameters. And then they get punched into the matrix. In this case, 3 levels, 3 colors, and you see the catastrophic moderate results in intolerable. Okay, so we know we got to do something here. Again, the description here. Okay, so we know we need to do some risk reductions. So let's talk about that next. Back to this. Okay. So sorry, got lost. Risk reduction. Okay, sorry, risk reduction. Here we go. Yeah, sorry, need to cover that one as well. I thought it was separate. Separate, my bad. Risk reduction. Okay, so in this case, as we start with intolerable, we have 3 measures defined, and you can define as many as you want. And so this first one is of type design, where the requirement is a performance requirement, not like prescriptive as it is, by the way, in the EN. So the EN standard and the ISO in this chapter has a definition of how high the fence should be. And guess what? In that Paris example, that's the exact height of the fence. It's 1.10 meters. And when I asked the inspector said, hey, it's 1.10 meters. It meets the standard. I'm like, yeah, great. Let's do an OERA. And let's see if this withstands this case here. It will not. It will not, because a 1.10 meter fence is being jumped in no time. So here we're defining a requirement that the entrance queue light fencing shall be designed, because it's a requirement, so that a sole human being cannot overcome without assistance from others or tools. Okay, so that's the requirement. The solution then, so requirement, solution, the entrance queue line is designed with a smooth surface and of 2.1 meter height. So now, smooth surface, 2.1 meter, and the requirement says, okay, no help from others. Of course, if you got a group, of course they can overcome that. So, and then here, important, there's a reference into the drawing that shows the drawing of this fence, of how it's been designed. What is very important, you need to do a follow-up risk assessment. And you need to do at least one follow-up risk assessment after all your measures. In ADVANTIS, we require you to do a follow-up after every step, after every risk reduction measure. So here's your follow-up. Severity, still the same. No change from the initial assessment, because if it happens, if this event, as described up here, happens, it is still catastrophic. So the severity has not changed, but the probability got reduced due to the above measure. Again, that's just the team saying, look, 2.1 meter shall be enough to bring it down, but not improbable, only remote. Because there is still a small chance that, yes, there's going to be two guys and one helping the other, or he shows up with the ladder or with the rocket bag. And so there is a small chance it's still going to happen. That's why we say undesirable. We're not done yet. Okay, so next measure. Also of design. Closed circuit TV camera covering the entire entrance queue line area during regular operation. And here, so this is the requirement. And here is the document. This particular PDF shows everything about this CCTV camera. Okay, follow-up assessment, no change on the severity and no change on the POO, because having a camera system is just doing you no good unless somebody's watching it. So this measure needs additional measure. Okay, got it. So third one, operations. Standard operating equipment shall require the lead operator to continuously monitor the CCTV camera during normal operation. The ride shall be stopped immediately in case of any person attempting to intrude into the ride envelope. And then here's the solution is the link to the chapter of the SOP where this is being addressed. And you could go on, you can then put on other requirements such as training, that these operators get trained and assessed periodically, yada, yada, yada. And that finally gets you down to improbable. So now you have a solid case document. And this is specific. Again, this is an actual example. Unfortunately, well, nothing has happened yet. Okay. Are we in time? 77 minutes. We're good. Yeah, we're good. Okay. So go back here, here, here. Okay. Last step, results. So we've changed this one recently from documentation to results. Just a second. Okay. Stefan said we have a lot of questions in the chat. So yeah, let's do that real quick before we cover the results. Okay. Let me get him on stage. Okay, Stefan, you're there. Here we go. You're on mute.
Oh, sorry, yes. Yes, I'm here. We have since some minutes the question from Jacob. So the occurrence is that the hazardous situation is present and it causes the harm. This is the first question. Would you please answer, Philipp?
Yeah, yeah, I can. Not sure I understand. So the occurrence is basically the transition from the situation, which is always present when you have people in a hazardous zone. That's always there 100% of the time. When people are in a hazardous zone, you have a hazardous situation. That's a given. But nothing has gone wrong. And at that point, in a hazardous situation, there's basically three things. There is a human not behaving like the person in that hazard zone not behaving the way you anticipated. There is a technical failure of some sort, that the system did not behave the way you thought. And the third category is environmental, that something from the outside is happening that you didn't think of and that is causing harm. So those are the three categories. That's why within ADVANTIS we have on the hazards list, we have these three categories, and that's also separation that the EN standard has. So those are the three things, the categories, how things can go wrong. And when things go wrong, that's when you transition from the hazardous situation to the hazardous event. And there is a certain probability that the person is misbehaving. We're not allowed to say misbehaving. Is behaving not as foreseen or expected, or there is a certain probability that the system is failing. For example, an unintended start of a motor. There's a certain probability that if it's not a safety-related component, that thing just automatically starts. And that's basically, again, this on this chart, what we're trying to explain. Hope this answers it. Okay, let's go next question. Stefan, you're still there? We got Stephen Smith. Could you also include frequency of vehicles passing? Let me get back. Jacob just answered. As a clarification, would the occurrence be that the person has jumped the fence or that the person has jumped the fence at the same time as the vehicle is there? Very important, the second one. Because if I word out, and that's why it's so important that you clearly word out your hazardous event. And the hazardous event, let me go back here. The hazardous event says participant hit by vehicle during recollection of cell phone, because only that's when he gets harmed. If he's doing this while the ride is whatever under maintenance, it's obviously a non-issue. He's going to grab his cell phone and carry on. But the hazardous event is clearly saying he's being hit. That's where he's being harmed. That's why we're saying catastrophic here. So it's clearly, on your clarification, it's the second one. And that's why we're saying that it's a moderate probability, because there is most likely a high probability of people jumping that short fence multiple times, but they're just lucky and not being hit. In this particular case, this ride actually has stones and bushes, so they can actually hide behind them. You can't even see them. Once they jump, you cannot see them back there. It's a very dangerous situation. So that's here the justification. So it is jumping the fence and the vehicle passing. That leads to the collision, and that's the moderate probability. Okay, hopefully we've got Jacob satisfied. Let's move to Stephen Smith. Could also include frequency of vehicles passing that point cycle. Yes, absolutely correct. Yes, in this case, we have like a 45-second dispatch interval. So yes, think of that. Every 45 seconds, there's a vehicle coming. Good input. Thank you, Steve, for that. Jim's got a question. does your software system guide users with connection to the various standards section like you show in 4101 section of your example, or did you have to type manually? I typed that manually for now, and that's why it's an optional entry. What he's asking here is the design piece. But point is well taken, because these kind of recommendation, although it's a bit difficult to parse depending on how people write the requirement, basically, we would have to figure out what chapter you eventually you're dealing with based on what you're entering. So as Stefan is on board here, something to look into that we put this reference in there. The other challenge is we can only put the reference to the chapter, obviously not the content for copyright purposes. It would be nice to just, put the standard content in there, but we can't do that. They're protected. Okay, Jim had more questions. For example, for the ride example CCTV documentation package, does your system house those documents or allow links? We are actually in the process of doing exactly that. So we are currently looking at having server space secured so that we can allow you to upload these documents on the server. We're also thinking like you can upload pictures. Pictures are sometimes worth 1,000 words, as the saying goes. So that you can complement the risk assessment report with pictures and documents. Obviously, we have to secure all the data. Now we have documents from you on our server, so we were well aware of that. So we're currently upping our security system. So this is the first announcement. We will have two-factor authentication available soon, voluntary at first. So stay tuned for that. And then we will move towards having data space available. Yes. So then we can, as you said, we can put a link there, so it's automatically linked. But ultimately, what matters is the risk assessment report, which is where I'm going to go next to show you how such a report would look like. Thank you, Jim, for the input on the viewing license. Yes, I'll have to look into that with EN and ISO, and also ASTM. It would definitely be nice to have a link to the standard. So I think Stefan, I think we've got them all covered for now. Questions? But I was going to
only the comment from Jacob as a clarification.
Yeah, that was his follow-up.
Yeah. No, then it's fine. Yes, thank you.
Okay, good. So let me get back. We'll get out of here. Okay. So 15 minutes ago, we're good. So on the result side, basically, we're asking for two things at ASTM in this section 10 result. We clearly say you shall prepare a risk assessment report. That's one element. And the other element is the transfer of risk assessment information. Very important, as I mentioned early on, especially now with having multiple parties doing multiple risk assessment eventually on one ride. Well, not eventually. This will happen. And so it is important that this risk assessment information, and it's clearly not just risk that need to be transferred. So let's talk about the report first before we talk about the transfer. So the content is basically what we just talked about. All these different steps, they need to be covered in this risk assessment report. And what is important not to miss is exactly the surrounding information, like the prerequisite, such as what is the scope, how is the scope defined, what is the method. All this information needs to be in the report. I've seen many risk assessment, basically Excel spreadsheet, created some PDF out of it, where there is none of that information is in there. No scope, no method, nothing behind it, just some numbers and some indicators. Guys, this just, that doesn't work. That does not work. So going back to ADVANTIS, so we have this project here, roller coaster, small little project. What you do is you print report. You can configure it of what to include in your report, and then you click PDF report, and boom, you got it. And so you got a 35-page document in no time. And that's what we like about it, because all the information is in a database. It can be edited anytime, going in reverse, not just forward. You can change somewhere one word and it gets updated in all your cases. So try that with Excel and Word. So anyway, this is just a quick glance of how this looks. Scope, for example, all the definition, all these things in here. Risk assessment method, risk, your matrix, all that information is here with the author, and then the overview, and then this is how your results would look like. Hope you guys can see it. It's a little small.
Could you please increase it a little bit? Yes.
Yeah, sure can. Yeah. So very similar to how the software looks in a top-down arrangement. You've got your hazard identification, your initial estimation, evaluation, and then your various risk reduction measures. So, with always requirement, standard reference, solution, and the follow-up. Okay. So basically then it goes on and on and on. So just wanted to show you how this looks at ADVANTIS.
Stephen has also a question. Are the universal global risk built in, like with pull-down menus that would allow you to make selections to speed the process? Could you please show the different hazards what you already have, that they can select it easily?
Oh, yeah, sorry. Yes, so within ADVANTIS, we call them cases. So every hazardous event is basically a case. And in a case, you first start with your hazard identification. So here we have a list of hazards. And this list actually starts with all the hazards that the EN standard gives us already. There's 25 hazards preloaded that are in there. And then you can add your own as you wish. You create your list, and you can group them by category and by ID. So you can have within your company, you can have your own list of hazards. So then you just pick it, you pick your task, and you're done. So.
To select the task and then also the hazard and so on.
Let's just see here. So in a new case, you just select your task, and then you select your hazard, and then you're done. What you need to do is that very prescriptive or specific hazardous event. That is very important. That's clearly defined. That's why we ask you to define that in a sentence, and then you give it an idea and the case, and whatever information that is mandatory shows up like that, so you can't save it. And that's how you have your new case. Okay. Muriello has a long question. I'd like to hear your thought recommendation on performing qualitative versus quantitative risk assessment. In my experience, a qualitative likelihood such as moderate may have very different meaning depending on who you're talking to. For example, someone could be thinking a probability between 10 to 20% is moderate, versus somebody else may say that moderate likely between 20 and 60, etc. I totally agree, Muriello. Fact is, when I first presented the concept, and that was back in 2007, to this industry about quantitative measures or assessment, I got so shut down by these guys. They're like, are you out of your mind? This is way too specific, because I know other industries work like that. But as a starting point, we believe now that we got to go qualitative, where pretty much every user can define their own terms and also their own numbers behind it. So what I mean by that, if we go into this project, into the project settings, we got the matrix. So this is the matrix we're using for this particular project. We can change the definition of what we mean by a certain probability to whatever. So right now we're saying moderate. What moderate means is it will occur several times. The hazard can be expected to occur often. So if you wish to put specific numbers in here, go for it. That's fine. You know, this is totally up to the risk assessment team how specific you want to be. So here, improbable, the definition, unlikely to occur in the system life cycle. It could happen. It's all probabilistic. It could happen tomorrow, but it's unlikely to happen within the system life cycle, because we never say never. What is important as an advice for a risk matrix, you have to get to the green in this axis, and you have to get to the green in this axis. If you don't have that, and I've seen many risk assessment that are orange here or orange here, if you don't get to the green, it'll be tough to get a follow-up risk assessment done if you never get to tolerable. So recommendation there. So, but again, you can change anything here, letter, number, up, down, anything. You can change all that to whatever you feel like. Same on the risk level. If you want pink, sorry. If you want a different color, make it pink. So it's all configurable. Hope this was okay for you, Mariella. Good. We got one more question from Valer. When someone makes a change at any point in the RA, is there a way to keep track of it? I'm thinking along the lines of revision control. Yes, good question. Yes, you see here, we've got change history. So the way change history works, as long as you're creating draft reports, there is no entry here. As soon as you start printing your final report, so it will no longer say draft on it or not for production, at that point, we start tracking all your changes. So we will then have entries in the change history, which case has changed, which if the case has been deleted, and also new cases, yeah, which case has been added ever since the last final report was printed. So yes, we do have that. Yeah.
But we can also say during changing something, you can add some comments. This is one point. And it's also in background, we record everything, what you're doing, when you're doing, and who is doing it. So it's the system is concurrent, and we can also work together. Multiple persons can work together on the same risk assessment, and the system records everything. So in background we have it, and in the future we intend to provide also more functionality to let the user know who has changed what when.
Mm-hmm. So what Stefan is referring is this one here. You can enter notes. So you can add a note, so you know who added a note when to the team. So, and you can do that pretty much on every step here. You can add these notes, and then they'll show up. So I'm cautious of time. We have about 5 minutes left. Jim, thank you very much for your positive comment. And yes, it is a challenge doing everything at the same time, but we're trying our best to teach on the content, and then also eventually bring the tool forward that it will help. I mean, that's ultimately the goal. And that's actually kind of where I was going to go next, just real quick on the difference between form and content. What we're really trying to accomplish is any document out there that you create, it has a form and it has content. And if you're using an open tool such as Excel or Word, you basically always work on both. You work on the form and you work on the content. And then every document, when it's being looked at from like a third-party inspector, for example, they look for correctness and completeness. So again, if you're using an open format such as Word and Excel, you have to consider form and content. What we're trying to do with ADVANTIS is we take care of the form. We make sure the form is correct, and it's correct and complete. So you don't have to worry about that, which means you can ultimately only focus on the content and don't have to worry about editing things and such. This all comes automatically. As you saw, you just put print and you got your report. No more editing. So that's where we see a lot of effectiveness for your development work. So last few words on the transfer. This is, again, it's very important that this is being communicated between the parties as early as possible. So this is all what is not within your scope. So in ADVANTIS, we have the ability that you create a residual or transfer risk report that just highlights those risks or those cases that have not been fully mitigated. Or if your counterpart, let's say the manufacturer uses ADVANTIS and also the park, they both use ADVANTIS on a given project, you can actually forward those cases within the platform. They automatically show up with your counterpart on the other company. So they see, oh, okay, those are the risks I need to, or those are the cases I need to integrate and look at. So that's where we see, enhanced safety by this full integration between the two parties, one doing a DRA, the other one doing an OURA. So that was actually the end of the official portion. Is there any other question? I don't know if we have time. What time is it? To do, time's almost up. I just wanted to touch real quick of where we are on the design side, because what you've seen so far basically represents the top blue corner of ADVANTIS. So this one here. So now we're working on the red box, which is the design, and we're pretty far along. We're now at beta release, so we're gonna have some beta customers that start testing it. And let me just jump into it real quick, just as a glance, first peek. I'm gonna go over to our development server of how this looks like. So you will have not only analysis, you're gonna have design, and in the future validation. So on the design side, if you have a safety function, basically from the SRS, from any given case, you will then have to design a safety function. So your safety requirement specification tell you what needs to be done. In this case, we're talking about a block system, transition between two blocks. So if B02 is occupied, you shall not be able to enter that block. So the block break at B01 shall stay closed. It's a performance level E. So all this comes out of the analysis portion, which we haven't had the time to look at in this short presentation. But this is then how the top level block diagram will look like on the hardware side. Very similar to what a Sistema report produces, but we definitely want to do more and want to do better than Sistema, allowing you to more flexibly design these subsystems where you have all your components entered. And sorry for you guys that are not controls, you're probably tuned out by now, but the controls guys know what I'm talking about because they're required to put all this information into Sistema. Now you can enter it here. As a matter of fact, we have full VDMA interface integration. So all these components are already automatically entered in the database. We manage that for you. So if Siemens comes up with a new component or pills and they update their VDMA library, it's automatically done by our staff that we inserted. So these components are all in there for you. You just have to pick them, select them. For example, Rockwell Automation, Point.io, boom, done. So you then can create the functional channels of how these, in this case, the selector switch is wired to an input module and then as an input subsystem. And then you define your various subsystem on the hardware side, as well as, and if I scroll down, there's a lot of information to be entered on the output module, brake control, all these components. I haven't entered all these, but where I want to get to, we have the link to Sistema. So right now it is a link. You still have to do Sistema, but I guarantee you in a fairly short time, we're going to have all the functionality what Sistema has, which is basically just a calculation of the ISO 13849 standard. All these numbers are going to be in here, so you don't need Sistema anymore. We automatically produce the performance level out of this tool. But we go further. We also have the software risk reduction portion. So you've got your software blocks for any given safety function, your block diagram, and then your cross-reference into your actual code. Whatever your code looks like, this is the reference into your code. So you have a complete documentation package in the future on the design side. So we're very excited to be able to release this very soon. Again, we have beta customers testing it right now. And then, of course, the last piece is validation, which will be even more powerful when we auto-generate all the test reports, the FATs and the SATs based on the safety function. This will be very powerful. But this will probably be 2022 until we get there to do that. But we've already started nailing down or writing down the requirements of what this module should be able to do. So again, I want to be cautious of time. We're 3 minutes over already. So let me get back to the presentation. Okay.
When you go to our website, you see all the different links to our channels like YouTube, LinkedIn, Facebook, and so on.
Exactly. So website has all the links. Here's my email in case you have any more specific questions. And sorry if I had to rush a bit at the end, but I hope every one of you got some takeaways from this. And again, we'll do more. If you have any suggestions of what in particular you're interested in, we're happy to address it and give more of these presentations. So thank you from my side. Stefan, any final word? You still look good.
Thank you also for my side to you, Philipp, for the good presentation and mainly for all the participants. It's great to see you. Thank you very much.
Thank you, guys. Cool. Thanks. Take care.